After the hybrid system is ready, you've pushed the button twice with it in park and your foot on the brake. You must select a gear in order to drive the vehicle. This is a photo of the gear selector. On the left, we're showing you the Prindo on the dash. The position selector on the dash is right underneath the ready light on some models. And on the right, we're showing on other models, it takes on the shape of the gear selector itself and shows you the same Prindo, the gear selected. The Prius shift selection inputs are important. The Gen 1 Prius is going to use discrete switches for the main gear select signal. That means every time a gear is selected, a discrete switch is going to give us a voltage change. The sub-gear select signal is an analog voltage. That means every time we change and select a different gear, we're going to get a different voltage level. Here we show the drawing of the park neutral switches on the left, the hybrid control ECU on the right, and the circuits that run between them. The hybrid control ECU has 4 connectors. We're going to move that up out of the way and show you that we're talking about connector H13. And these are our cavities for the individual circuits that come from the park neutral switches to the hybrid control ECU. When we talk about an individual circuit, one of the mains, the hybrid systems use a lot of redundant circuitry. And we said that's because the drive-by-wire function, it's a safety backup. So when we're talking about the mains, they're going to have 2 states, high or low. High is when the voltage is 4.0 to 4.8. So when a gear position is selected, that individual switch is going to take the voltage high. When a gear is not selected, it's going to be low or under 1 volt. As in this example, we selected park. The circuit goes high, 4.0 to 4.8 volts. All other mains should be low because they are not selected. So as we go down through them, the neutral goes high when selected, under 1 when not in neutral. The drive position goes high when selected. When it's not selected, it's under 1 volt. The B does the same thing when we select B. The reverse, identical, 4.0 to 4.8 volts when we select reverse, but when we don't select reverse, we select something else, its circuit should be under 1 volt. Now the sub, or the redundant circuit, starts with 3 wires. First one is VSFT. That is the 5 volt reference for the sub selector. The sub selector signal, the SFT, is going to have a specific voltage when a specific gear is selected. And the chart shows us that a half a volt in park, 2 volts in reverse, 3.4 volts in neutral, 4.0 volts in drive, and 4.5 volts when B is selected. And the FSFT circuit is the sub's ground, the sub shift selector position's ground. Now we're going to do this with scan data if we can. I have selected 3 PIDs to show you. I did not select all the PIDs available because I don't want your eyes running around a scan tool. I want you to see what we're doing here. So if we select the park position, our PID called shift sensor main should be high, just like the voltage. It should be between 4.0 and 4.8 volts. The example here is 4.6. Now the sub, the analog voltage, goes to a half a volt, and then we have a PID shift sensor position. So as you move the gear selector around, the voltages and the shift sensor shift position should change. Here we have park, here we have reverse, neutral, and you can see they change as we change the selected gear. Here's drive and here's brake. So you can do this right from the driver's seat with scan tool data. You can also use diagnostic trouble codes to help diagnose the Prius first generation neutral switches. The DTC is going to help point you in a diagnostic direction. For example, the P1780 states that the park neutral position switch system malfunctioned. Wow, that's not much help. That's ambiguous at best. This DTC says, hey, there's something wrong with the park neutral position switch system. We don't know what it is, but you better go find it. If this is what your scan tool gives you, then you're going to be using a DVOM in the charts we just went over. Now, if your scan tool gives you the information codes, the 3-digit codes, it's going to give you more specific information about the problem. For example, if we have a 3-digit code of 118, it gives us a specific. It doesn't say, hey, there's something wrong with the park neutral switches, go find it. It says, yeah, there's something wrong with the park neutral switches. In fact, 2 or more shift lever position signals are high at the same time. 2 or more shift lever position signals are high at the same time. Here we ask you to use some common sense and take just a moment to ensure that you understand what this is saying. 2 or more shift lever position signals are high at the same time. Now, they must, although they don't say it, they must be talking about the main and not the sub. The sub has a specific voltage for each selection. Now, in the main, we know one is high at a time and all others will be low. So, reading carefully what the code is telling us tells us where to go test. We can test it with a scan tool or a voltmeter here. So if we're going to use a voltmeter, you can see that 1 should be between 4.0 and 4.8, and all others should be under 1 volt at a time. If we put it in park, we should have the high. Everything else should be under 1 volt. As we look at this circuit, everything was under 1 volt, and only the park was high because that's what we selected. But that's not what the code is telling us. The code is telling us that we have a problem. The normal example I just showed you by the 2 arrows on the right, park, neutral, reverse, brake are all under 1 volt. We selected drive, and we have what we're supposed to have, 4.0 to 4.8 volts. The bad example over on the left shows us that, yeah, we selected drive and we have it high, but park also shows high at the same time. We verified a code. Now that may not seem like much at first, but now we know we are down to the park neutral switch assembly or a wire. It is not a false code from a hybrid control ECU that has a problem. So the bad example says, hey, if we measure here, we're going to see 2 of them high. The 119 tells us a little bit different story. It says no shift position signals are high when the sub signal indicates a gear selection. So our sub has a specific voltage on it telling us that we have selected a gear, but none of the main signals went high. So we're going to check signal levels to identify which is the problem. Here the sub signal shows us one of these voltages when we select one of these gears. Park, half a volt, reverse, 2 volts, neutral, 3.4 volts, drive, 4.0 volts, brake, or B, 4.5 volts. So we're going to have one of those down here on the sub selector. It's showing us it's above a half a volt. Something's been selected. But when we look, there's no signal from any of the mains. They all indicate under 1 volt. Verified the code. 120, the sub shift position signal is missing. That means there's no voltage there. So we're going to check for an open or short to ground or the unit itself. Here we have 4.3. That is high. That's between 4.0 and 4.8. Everything else is under 1 volt. So the main seems to be working normally when we select park. But on our sub, our SF T, we only get 0 volts. It's a wire or the unit itself. This is not brain surgery. Now on the 121, the main shift lever position signal does not agree with the sub shift lever position signal. We're going to diagnose again. The sub shift lever signal should always indicate one of the below. On the right there, in park, reverse, neutral, drive, B, it's always one of these voltages that we've been talking about. The shift lever and sub shift lever signals agree. So as we go down and move at the park, yes, they agree. Reverse, neutral, drive, and brake, they all agree. The sub shift lever signal is agreeing with the main. Now here's where it doesn't agree. We put it in park and our main reads correctly, but our sub shift signal reads 2.5 volts and it should read 0.5 volt. And as we move through, it does not agree with the main signal. So this code, this information code, indicates that one or more of the sub shift signals don't agree with the main. It's an integrated unit. You're going to check powers. You're going to make sure that you have good power, and you're going to make sure that you have good grounds, and then you're going to end up replacing the unit as necessary.